Oh my goodness, welcome to video 5. Remember, we're combining section 5.8 and 5.9 together, where we're analyzing the graphs of H prime and H double prime, or F or G, whatever the name might be. We're going to do example 3 here a little bit quickly because it kind of goes with what we were talking about in the previous video. And then I really want to get into example number 4, which brings in concavity. So we're looking at the graph of H prime. This is H prime. Again, there's a typo. I don't know. Maybe there's a formatting issue. Determine the intervals where the continuous function of H. So they give us some information here. The function is continuous. H prime is not continuous, but the function H, the original function, is. Where H of X is increasing and decreasing, as well as any relative extrema for H of X. Okay. So what should we do? Well, we should look for where are those places where the derivative is equal to 0. So the derivative is equal to 0 here, and the derivative is equal to 0 here. Ooh, where is that? Where is that? We might have to approximate here. So if I draw my little sign chart of x's and h prime values, we just said that at 0 and I'm going to say 6.3, I don't know, 6.3 we'll say. At those two places, the derivative is equal to 0. What happens to the left of 0? Well, to the left of 0, all this part of the graph is negative. That means my slopes are negative. But be careful, this doesn't go on forever. It looks like it stops at -2. So -2 is the starting point. It doesn't go to -infinity. But all the slopes are negative on this side between -2 and 0. Between 0 and 6.3, which I said, all these parts of the graph are positive. So that means H prime, the slopes of H, are all positive. And then after 6.3, until I get to 7, I have negative part here. But then after 7, something happens here, right? Something happens where there's a break. And then after 7, I have positive, positive, positive. Okay. So the question is, where is it increasing, where is it decreasing, and what the heck happens at 7? Does a derivative exist at 7? It does. It's telling me that it is 3, right? But it's also there's a change in my negative part of the graph to a positive part of the graph without any smooth transition. So we're going to say this. H of X is increasing on intervals between 6.3 and 0 and 6.3, or for x's that are greater than or equal to 7, because h prime is greater than 0, it's positive on those intervals. And then we can say h of x, not h prime, h of x is decreasing on -2 less than or equal to x less than or equal to 0, or 6.3 less than or equal to x less than or equal to 7, because h prime is negative, less than 0, on those intervals. Are there any relative mins or maxes? So if I draw H, according to this, I have negative slopes, positive slopes, negative slopes, positive slopes. So what's going on here? Well, I think I have a relative minimum at x equals 0 and at x equals 7. So H has a relative minimum. Some people call it a local minimum. Has, or maybe not a, has relative minimums at x equals 0 and x equals 7 because h prime changes from negative to positive, and h has a relative maximum at x equals 6.3 because h prime changes from positive to negative. Now, I'm abbreviating a lot of stuff here. Maybe you shouldn't abbreviate, but I'm trying to quickly write the ideas that I'm saying out loud. So I know that h has a relative maximum at 6.3 because my derivative changes from positive to negative. That means it goes from increasing to decreasing, right? So this is how we can analyze number 3. I'm going to have to pause the video here. I think my computer is running out of power. So we'll come back, and unfortunately, we'll have to do video number 6. But we'll finish up fairly quickly after that.